Class, today we're going to look at the second part of Objective 8.5. That's Chapter 8.5, Objective 2. I think your notes might say 8.5.1, so there's an error on your notes. The topic is to be able to solve logarithmic equations. So on the right, I need you to recall that log base b of a equals n. That's its logarithmic form, but if I change it into its exponential form, I have b to the n equals a. So we have to be able to go fluidly between the two. If we ever get stuck in one form and we need to solve that problem, we can quickly put it into the other form, and that might help us solve the problem. So example 6 says solve log 2x minus 2 equals 4. Now there's nothing as a subscript for log, so we know that's log base 10 as I've written. Now we're just going to change that into its exponential form to solve for x. So this becomes 10 to the 4th equals 2x minus 2, and now it just becomes an algebra problem, or a simple algebra problem. 10 to the 4th is 10,000 equals 2x minus 2. I'm going to add 2 to both sides, so it's 10,002 equals 2x, and then divide by 2. X then becomes 5,001. I'd encourage you to put this into your calculator now. Log 2 times 5,001 minus 2, close parentheses, and just check, does that equal 4? And it certainly will. Now go ahead and do check understanding 6. Solve log 7 minus 2x equals negative 1. Again, check your answer. Please don't scroll through this until you have actually made this attempt on your own first. I hope you've solved this problem. I'll walk through it with you. Log base 10 of 7 minus 2x equals negative 1. I'm going to change this into its exponential form, so that's 10 to the negative 1 equals 7 minus 2x. The negative exponent, known as an exponent, will simply flip that 10, so now you have 1 over 10 equals 7 minus 2x, and again now it becomes a simple algebra problem. Subtract 7 from both sides. Negative 7 plus 1/10 is really negative 6 9/10, or negative 69 over 10, and I'm going to multiply both sides by a negative 1/2. The result is 69 over 20, or approximately 3.45. Again, check this on your calculator. Put 3.45 in for x, and see if you do indeed get negative 1 as a result. Then we'll move on to example number 7. Alright, here's example 7. 3 log x minus log 2 equals 5. Again, we have no subscript, so we know our log is base 10. So I've rewritten that. Log, or 3 log base 10 of x minus log base 10 of 2 equals 5. Using our log rules, I can see that I am subtracting the two logarithms. So again, using the log rules, that subtract means I can divide x cubed by 2 and just write it as a single logarithm. So now I've got log base 10 of x cubed over 2 equals 5. Alright, I've got one logarithm, a single logarithm, and I'm going to change it now into its exponential form. So that ends up looking like 10 to the 5th power equals x cubed over 2. I don't have a logarithm involved anymore, and I can just solve for x. So 10 to the 5th is 100,000. I'm going to multiply both sides by 2, so x cubed equals 200,000. And then in order to solve for x, I have to get rid of the cube, so I'll do that by taking the cube root of both sides. You can do this on your calculator. The cube root of 200,000 is approximately 58.48. Like the other ones, I encourage you to check this on your calculator. It's good calculator practice. So you would say 3 log 58.48 minus log 2, and see if that equals 5. It might not be exactly 5, but it should be very close The reason it wouldn't be is because I did an approximation for the cube root of 200,000. Alright, check understanding. We've got log 6 minus log 3x equals negative 2. If we work through this, the subtraction again tells me I can divide 6 over 3x. So I've got log 6 over 3x equals negative 2. And that's just a fraction, so 6 over 3x is really just 2 over x if I simplify 6/3. Now I'm going to change that into its exponential form. 10 to the negative 2 equals 2 over x. I'm simply going from its logarithmic form to its exponential form. And now I just have a proportion to solve. 10 to the negative 2 is really 1 over 10 squared. I'm getting rid of the negative exponent, and I can do that by flipping the value of 10. 10 squared is really 100, so I really have just 1 over 100 equals 2 over x. I'm going to cross multiply, and x equals 200. Again, solve, check that. Put 200 in for x, log 6 minus log 3 times 200, and your result should be negative 2. These logs are exciting stuff, so there's really no reason to be bored. You can work on your assignment at this point, and you should have no problem doing that.